Welcome to the third video of this series on building an AI-powered voice recruiter assistant. If you haven't seen the first and second video of the series, I highly recommend checking them out first. We went deep into the why behind this project, the problem it solves, the big picture architecture, and the AI agent design. Just to quickly recap, here is how the system works. A recruiter shares a Calendly link with a candidate. The candidate picks a time, and we get a webhook with their info. That triggers a job and AP scheduler to run at the scheduled interview time. If a resume is available, we parse it ahead of time using the resume AI agent. Then we initiate a real phone call using VAPI. And the interview agent takes over, asking questions, listening, and following up. Once the interview ends, the evaluation AI agent kicks in, scoring the candidate and updating the database. And all of this happens with zero manual intervention. Why don't we see a quick demo?
Am I speaking with Jerry?
Yeah, this is Jerry.
Hi, Jerry. It's great to meet you. Do you have about 30 minutes for our conversation today?
Yeah, absolutely, I do.
Awesome. Thank you. I'm Tom Lanigan, a senior software engineer with Big O1. I'm here to guide you through this interview and assess your fit for the senior software engineer position with Joy and Grace. Are you ready to dive in?
Yeah, absolutely.
Great. Just to let you know, I'll be speaking on behalf of Joy and Grace, the consulting firm looking for the right candidate for this role. Let's get started with your experience. Can you please describe your current project and role?
Sure. I'm currently working as a backend engineer on a financial services platform built with .NET, .NET Core, C#. My role involves designing APIs, optimizing SQL Server queries, and deploying services to Azure using Azure App Services and Azure Functions.
Thanks for sharing that, Jerry. It sounds like you're working on some interesting technology. Can you walk me through the system architecture you worked on for this project?
Sure. We followed a microservices based architecture hosted in Azure. Each service is built with .NET Core, communicates via REST and Azure Service Bus, and uses SQL Server, in some cases Cosmos DB, depending on the use case.
Thank you for detailing that architecture, Jerry. It's interesting to hear how you leverage different databases based on the use case. Why did you choose those specific technologies for your project?
Cosmos DB gave us the fault tolerance and scalability that we need. That's why we chose to go with Cosmos DB for certain use cases.
Thanks for explaining that. It makes sense to use Cosmos DB for those reasons. What trade-offs or challenges did you encounter with that stack?
One challenge was managing distributed transactions across microservices. We had to use eventual consistency patterns and spend time fine-tuning performance, especially with large-scale SQL queries under load.
Thank you for sharing that challenge, Jerry. Managing distributed transactions can certainly be complex. Moving forward, how do you use dependency injection in .NET Core?
It was a quick peek at the interview agent live in action. And honestly, it's always cool to see how natural and structured the conversation feels. The agent handles the flow confidently, responds politely, and even manages follow-ups without sounding robotic. This is exactly what we are going to build, and I will walk you through every step of the way. If you want this Recruiter AI voice assistant or want a voice assistant, something completely custom, we can help. Whether it's handling inbound calls, following up with leads, or automating something totally unique, we will help you figure it out. Book a free consultation call with us. Link is in the description. Back to building this awesome assistant. In this part of the series, we're going to look at how this actually works under the hood. We will dive into the code base, see how the project is structured, and how the agents are defined, and how prompts are crafted for clarity and precision. We'll start with the database model and database integration, and then we'll walk through the agents one by one. how the resume agents extract insights, how the interview agent runs the conversation, and how the evaluation agent evaluates the candidate. So, if you're looking to build something with real world AI agents, not just playground demos, but actually functional systems, this is where it gets real. Let's start with the code walkthrough, beginning with the project layout and how we model the candidate in the database. If you want to follow along or poke around the project yourself, the full source code is on GitHub in AI in Real World under recruiter-agent. Link is in the description. Here is how to get it running locally. If you a Git clone first, then go into the project and open VS Code. Just issue code space dot and it should open up VS Code. Once you have the VS Code open, set up a virtual environment by typing python-m venv space dot venv. Once the virtual environment is created, activate the environment by calling activate.ps1 for Windows and just activate if you're using Mac. Finally, all the dependencies you need to run this project is defined in requirements.txt file. So to install all dependencies, run pip install-r requirements.txt. To run the project, you need to provide API keys to OpenAI, Supabase, Calendly, etc. .env.example file has a full list of environment variables that you need. Rename the file to .env and provide all the keys, and that is it. You will be set up and ready to explore. Let me walk you through how the project is organized at a high level. Here is a quick overview of each folder. SRC folder. This is where all the core logic lives. Everything important happens in here. Within SRC, we got the API folder. All fast API endpoints stay here. This is how external systems like Calendly and Vapi interact with our app. Then we have our agents folder. This is where the AI agents live. Resume agent, interview agent, and the evaluation agent. Next, DB folder contains database interaction code, basically everything that talks to Supabase. Followed by models directory, defines pydantic models and data structures. We use these models throughout the project for consistency. Services folder hosts application level orchestration logic. For example, this is where we trigger the full interview process. Tools folder has utility functions and wrappers, things like the Vapi client, scheduler, and helper scripts. Run Python script, the main entry point to start the app. This kicks off everything, web server, background jobs, etc. Finally, we got requirements.txt, all your Python dependencies in one place. So it's a fairly classic layout, clean separation of concerns, everything in its place. This makes it easy to extend later if you want to plug in more agents or tools. Now that you know your way around the repo, let's jump into the database model because everything starts with the candidate profile. Let's talk about the database because this is one of the essential components of our AI voice recruiter assistant. I'm using Supabase for this project. It gives you a fully managed Postgres database, cloud file storage, and a beautiful admin UI, all for free to start with. If you have never used Supabase, think of it as Postgres on the cloud with few extra bells and whistles. In this project, we only have one core table, and that's a candidates table. This table stores candidate profile, resume experience to start with. Our agents will update this table with resume summary, interview transcripts, and candidates evaluation. The SQL to create that table is included in the SQL folder in the repo. You can use that to set up the schema quickly in your own Supabase project. Right now, I only have one candidate in the database, which is me. But in a real-world setting, recruiters could export a spreadsheet of candidates and either bulk upload into Supabase or write a script to push that data via the API. Now let's look at the code that connects our app to this table. In the models folder, we have this file, candidate.py. This is where we define the pydantic models that represent our candidate structure in code. And it's actually broken into clean components. First, there is candidate profile model. This is the candidate's identity and contact info, plus resume details. It is what we will use throughout the project to know who we are talking to. Next is resume summary. This gets populated by our resume agent after parsing. It is a structured way to hold insights from what's usually a very unstructured resume. We are extracting highlights, core skills, project examples, and any red flags, all from the uploaded resume. Then we have got evaluation models. Scorecard holds scores for system design, hands-on coding, communication, etc. Each score is on a 1 to 5 scale, and this becomes the basis of our candidate evaluation. And then candidate evaluation wraps this up with a summary and a final recommendation. Recommend or not recommend. We also have a pydantic model to represent the total cost of the LLM interaction and also to represent agent-wise cost of LLM interactions for each agent. Finally, the top-level candidate model combines everything. This single object flows through every agent, resume parsing, interviewing, and scoring, so all data stays in sync. Now let's jump into the repository layer where we actually interact with Supabase. Open up candidate repository Python script under the DB directory. Here is the first key function, getCandidateById. This function queries Supabase using the candidate ID, builds a candidate profile from the database row. If a resume is present, it will generate a signed URL so we can securely access the file. It then builds a resume summary from candidate evaluation object if the data exists. Finally, it returns a fully populated candidate object. This is the first thing we call before any interview, so the agent knows who it's speaking to and what data is available. Then we have update candidate by ID. This one takes in a full candidate object, builds a dictionary fields to update, skipping anything that is still empty, cleans up any null bytes important if resume parser returns garbage characters, sends the update to Supabase. We call this after parsing the resume, after interviews, and after evaluation. Basically, every time a candidate's state changes. There is also normalize phone function. This uses the phone numbers library to convert raw strings into E164 format, which is required for phone calls via WAPI. It also catches malformed numbers and logs an error. We also have clean null bytes function, simple but important. It recursively strips out bad characters that can sneak in from bad resume encodings. Without this, saving to Supabase can randomly fail or our prompts can break mid-call. And finally, upsert candidate from Calendly. This function is triggered by Calendly webhooks when a candidate books an interview. It looks up the candidate by phone or email and either updates their info or inserts a new record with the generated UUID. It also stores the scheduled interview time in UTC and sets the status to interview_scheduled. This makes the whole thing plug and play with Calendly. Together, this model and repository layer form the data backbone of the project. Everything else, resume parsing, the call flow, evaluation, builds on top of this clean structure. Next, let's take a look at the resume agent and how we go from PDF to parsed summary with just one LLM call. Right. Now let's move on to the resume agent. This is the first step in the candidate evaluation pipeline, and its job is simple but powerful. Take an uploaded resume, PDF or Word doc, extract all the important info, and return a structured summary that the rest of the system can use. The agent lives in the agents folder in resume_agent file. Let's break down how it works. At the top, we import the essentials. Since resume parsing isn't latency sensitive, we use GPT-4o for high accuracy and nuanced extraction. Model name comes from environment variables at runtime, making it easier to change it later at runtime. Now we define the resume agent. Let me unpack a few things. System prompt is the actual brain. We'll get to that in a second. Dependencies type tell the agent what runtime dependencies it has access to, in this case the candidate. Instrument equals true allows us to track and debug our agent through Logfire. The resume agent has access to one tool, which fetches and parses the resume. Fetch candidate resume. Our agent has access to the tool because we have decorate the function with @resume_agent.tool. Here's what happens in the tool. We get the signed Supabase URL from the candidate's profile. We pass that to parse resume from URL, which pulls the file and extracts the raw text. Store the parsed text in candidate.parsed_resume so future agents like the interviewer or evaluator can use it too. Let's now look at how parse_resume from URL actually works. It lives in the tools folder in file resume_parser. This utility supports PDF and Word doc formats. We use PDF Miner to handle PDFs and Python-docs for Word documents. This gives us clean, unformatted plain text. And yes, we also suppress PDF minor logs because they are ridiculously noisy. Now let's switch gears and talk about the prompt because this is really what makes the resume agent work so well. You will find the prompt in agent underscore config Python script under agents folder. It is defined as resume underscore agent underscore prompt. And here is what it says in a nutshell. You are an AI resume analyzer. Your goal is to populate each field of the resume summary object based only on what is in the resume. Be concise, be factual, and do not assume. Then it walks the agent through 8 specific fields one by one: experience summary, core technical skills, specialized skills, current project, notable past projects, education and certifications, potential red flags, and optional notes. Each section includes clear, opinionated guidance. For example, only include the core skills that appear multiple times. List flags only if something stands out. Omit fields that are missing. Do not guess. And finally, we show the model the expected output format, the full resume summary JSON with every field explicitly labeled. This helps the model return clean, parsable output every time. Here are a few things I've learned that might help you in your own agent design. Define roles explicitly. Start with you are an AI resume analyzer to ground the model. Be structured. Walk it through one field at a time. This turns an open-ended task into a checklist. Show the format. Always end the prompt with the expected JSON output. It massively reduces parsing errors. Allow omissions. If something is missing from the resume, tell the agent it's okay to leave it blank. This eliminates hallucinations. And that is it. We have turned a PDF or Word doc into a structured, usable data, and the rest of the pipeline now has the context. To recap, we use GPT-4o for resume analysis. The agent pulls and parses resumes securely via signed Supabase URLs. The prompt is highly structured and field specific. Output is clean JSON validated against Pydantic model. We extract skills, project summaries, educations, and flags all hands-free. This agent runs once before the call, gives the interviewer a head start, and sets the foundation for everything that follows. Next, we'll move into the interview agent, where we take the structured resume and turn it into a dynamic, multi-turn voice conversation. Interview agent. And I'll be honest, this is one of my favorite parts of the project because when you open the code, you see it's barely anything. Just a few lines of code, and that is it. But what's really wild is what this small block does. Without hundreds of conditionals, without tracking turn numbers or user state in Python, this single agent can carry a full 30-minute phone interview with context, patience, follow-ups, and even graceful call wrap-up. And all of that is powered by a prompt. This is really the power of LLMs in action. In a traditional app, replicating this behavior would have taken thousands of lines of logic, conversation state management, tone control, edge case handling, and more. Here, we do it with a carefully crafted prompt. Let's take a look. You'll find the prompt in agent underscore config file in the agents folder. It's called interview underscore agent underscore prompt. And it is big because it is precise. Let's walk through what makes this prompt so powerful. It starts by setting the tone and persona. You're Tom, a friendly, conversational senior software engineer. This is important. We are anchoring the model into a specific identity. Tom is human, senior, calm, and working on behalf of a real company. We explicitly say the call is 30 minutes long. We remind the agent that candidates might be nervous and they might repeat themselves or speak slowly. And here's a subtle but important instruction. Be patient. Give the candidate the benefit of doubt. We don't want the model jumping to conclusion if someone rambles or hesitates. The tone is clearly defined as warm, professional, responsive. That sets the emotional boundaries for how the agent should behave. Next comes the output schema. And this is very important. We make some key decisions based on what the model returns. The prompt tells the model to output exactly one JSON object per turn with 3 keys: agent response, turn outcome, and turn outcome reasoning. This format is crucial. It keeps the system consistent and easy to parse. We use this structure in our backend to decide when to end the call, when to escalate, and when to trigger follow-ups. We've defined an algorithm to instruct the model how to derive the turn outcome. This is the heart of the flow. We give the model a clear algorithm to follow, not in code, but in natural language. We have 5 turn outcomes here. Gatekeeper failure already interviewed. Gatekeeper failure in office not possible. Candidate requesting end call. Wrap up and normal. The first 2 gatekeeper outcomes are triggered the candidate already interviewed for the position or the candidate cannot meet the work in office requirement. The LLM will use the candidate requesting end call turn outcome if the candidate prefers to end the call. This could be due to a scheduling conflict or for any other reason. And finally, when the LLM is wrapping up the call, it will output the turn outcome as wrap up. And for the rest of the turns, the turn outcome would be set to normal. The turn outcome is very important. The turn outcome lets us control the end of the call logic without relying on timers or back-end state tracking. You'll see this in action when we see a demo. The next section walks through the model through each stage of the interview. Greeting and time check, self-intro and agenda, client introduction, role briefing, gatekeeper questions like have you already interviewed for the position or will you be able to work 3 days on site? If the candidate clears these, the agent proceeds to the actual interview. If the candidate does not clear these, we have instructed the model to set the turn outcome to one of the gatekeeper failures. We track the outcome and respond with a polite message to end the call. Next, the agent asks the questions defined by us to cover various topics. We ask a predefined set of core technical questions. If you're interviewing lots of candidates for a position, it is important to keep the questions static so it becomes a good measuring scale to compare all candidates uniformly and consistently. In this prompt example, we are interviewing for a .NET C# role. First, we ask questions on project overview, architecture explanation, technology choices, challenges, and trade-offs. This will help us understand the candidate's current job roles and responsibilities in the project. Next, we got some technical questions. And after the technical questions, we cover some wide range of topics like Azure and distributed systems, CI/CD, etc. And finally, a polite wrap-up and Q&A before ending the call. We also include fallback behavior for weird moments like poor audio quality, candidate confusion or mismatch, question related to benefits which a recruiter will defer it to HR. For each of these, we give the model an example line so it knows what to say without panicking. You will see most of the context to the prompts are dynamically filled at runtime. The prompt uses these placeholders for client name, company name, role title, role stack, role location, role schedule, interview duration, company description, and client description. These are loaded from .env file and read into the prompt via the config Python script. This means you can reuse the same prompt for different clients and roles, and it will always sound personalized. Just like the resume agent, this prompt works because the structure is clear. It walks through every stage: greeting, intro, screening, technical wrap-up. The tone is defined. We explicitly tell the model to be patient, warm, and responsive. The output format is fixed. The JSON block makes it easy for us to parse responses, no messy cleanup needed. We defined error handling. The model is never surprised. We gave it examples of what to do if something goes wrong. We included business rules as natural language. We don't need hard-coded logic to end the call. The model follows the rules right in the prompt. This is where LLM really shines. We are using natural language to define stage, tone, flow, and logic. It's a great example of how LLMs can replace hundreds of lines of brittle branching logic and give you something much more easier to debug, evolve, and maintain. This is a good place to stop the video. So far, we have covered the overall architecture and agent design. We have walked through the code for 2 agents, resume agent and interview agents, along with their respective prompts. We still have a lot to cover in this recruiter agent series. In the next video, we'll start with testing the agents we have built so far. Then we'll proceed with looking into evaluation agent. Next, we'll look into how we integrate with Calendly and finally adding voice support by integrating the agents with VAPI. We don't stop there. We will fully productionalize our code and deploy it to render. We have a lot to cover in this series. If you like what you have seen so far, subscribe to this channel and share it with someone who might find this content interesting. If you want this recruiter AI voice assistant or want a voice assistant something completely custom, we can help. Whether it's handling inbound calls, following up with leads, or automating something totally unique, we will help you figure it out. Book a free AI consultation call with us. Link is in the description below. If you like this video, give it a like and subscribe. And I will see you in the next video.